Hello everyone, good morning. Number 23 of ODE, where we're going to topic called equations of first order but not of first degree, right? So I will just go through the syllabus, right? On the very first video, I've given you the overview of syllabus. Let's show you the PPT of very first class. This is what I've started, right? So we have completed equations of first order and first degree integrating factors, and then we have also completed second and higher order linear differential equation with constant coefficient, and then second order linear equation with variable coefficient, that's called Cauchy-Euler equation. And then we also determined, we also completed method of variation of parameters, right? So we already completed all these topics. In this class, right? In this class, we are going to that is upcoming classes we are going to come this topic, that is equations of first order but not of first degree Roots equation singular solution, right? This is what we're going to start. This topic we're going to start. After this topic we'll be starting orthogonal trajectory, and then this topic, right? We're going to complete ODE, right? Almost we're going to complete ODE. We're going to start with the topic called equations of first order but not of first degree, right? We have already completed. The red ones are already completed, right? Okay. In the Telegram group, I have said that to recall all the methods of solving a differential equation of first order and first degree, right? Variable separable method, homogeneous integrating factors, and then exact differential equations. There are many methods, right? So what we will do is, in this class we're going to start how to solve the equations of first order but not of first degree. So we are going to classify this into 4 types: type 1, type 2, type 3, and type 4. In this class we will finish type 1, and in the upcoming class we will see type 2, type 3, and type 4. After that we'll move on to the next topic, right? So maximum another 6 to 7 classes we will be completing ODE, right? Yes. So we will start, right? So first what we will do is we will define what is meant to be equations of first order but not of first degree, right? So by looking at the sentence itself, it is easy, right? If first order, that means it will be dy by dx, but not of first degree. So we will have like dy by dx whole square, dy by dx whole cube, dy by dx whole power 4, like that. First order means dy by dx, not of first degree means degree must be greater than 1. If it is equal to 1 means we can already how to solve a differential equation of first order and first degree, right? Here we will have first order but not of first degree. It will be like dy by dx whole square, dy by dx whole cube, like that, right? First what we will do is we will define, right? We will define what is meant by a differential equation of first order and but not of first degree. After that we are going to classify them into 4 types. So we will start with type 1 in this class, right? First we will define, right, condition. A differential equation of of the first order but not of first degree, right? It's an equation of the form So I'm going to tell you the general format of a differential equation of first order but not of first degree, right? So it will be of the form naught, right? P naught p power n plus p1 p power n minus 1, p2 power n minus 2, and so on up to n minus 1 capital. N minus 1 plus Pn is equal to 0, right? Where the small p is dy by dx, that's it, right? So we have a small p is dy by dx, and this naught, p1, p2, and so on up to pn are functions of x and y only, and n has to be greater than or equal to 2, right? Because it should not be of first degree, right? Very simple. So this is dy by dx, right? This equation is same as p naught dy by dx whole power n, right? This p1 dy by dx, I'm just taking this p to be dy by dx, right? P1 n minus 1, or you can also take this p instead of this p naught p1 p2, not just some representation, right? Just take some a naught, a1, a2, a3, and so on. In that case, you will not, don't have confusion. Are functions of x and y only, and n is greater than or equal to. This will be in p1 dy by dx whole power n minus 2, 1, pn minus 1 is dy by dx plus pn is equal to 0. Both are same only, right? Because we represent the small p to be dy by dx, right? So whenever you see an equation of the form, some functions of xy into dy by dx whole power n, some functions of xy into dy by dx whole power n minus 1, it is called differential equations of first order but not of first degree, right? Yes. Now we're going to tell you the way of solving. We're going to tell you the way of solving a differential equations of first order but not of first degree, right? So it can be classified into 4 types, right? It can classify into 4 types. The first is type 1. Type 1 is equation solvable for p. Equation solvable for p, right? Equation solvable for p. Or you can also, don't want, you can also take this to be capital P itself, right? P naught x power n, P naught p power n, p power n or n minus or n minus. Right? This p is dy by dx, right? Okay. This p naught, p1, p2, pn minus 1, pn are functions of x and y. So equation solvable for p, this is called type 1, right? Equation solvable for, that is, suppose we have, right? Suppose suppose the equation of nth degree, right? In p is x comma y comma p is equal to 0. Suppose if you have functions of x, y, and p, if it is solvable for p, very simple, right? You just have to understand this UPT. If it is solvable for p, then that equation, right? Then it can be put in the form. Then it can be put in the form. If it is solvable for p, we have p is equal to some function of xy into p minus some function of xy and so on up to p minus some fn of x comma is equal to 0, right? Very simple. If it is solvable, you just have to compare this with, let us take some quadratic equation. Let's take some quadratic equation. X square minus 2x plus, right? It is solvable for x. That means we can write this we can write this as x minus 1, right? That is what we have written here. So this is solvable for p. So p minus some function of xy, p minus some function of xy. That is what I have written here. Since it is solvable for p, it can be put in the form p minus some function of x comma y into p minus some function of x comma y and so on. You just compare this with a quadratic equation. It is solvable for x. That means x minus this. These are factors, right? These are factors. Similarly, you just compare it. Now, you now equate every term to be equal to 0. Equate every term to be equal to 0. Right? Equation solvable for p means there will be an equation in terms of x, y, p. If that equation can be put in this form, it is solvable for p, right? So we want to classify them into 4 types. Type 1 is equation solvable for p. Type 2 is equation solvable for y and so on, right? First, we will concentrate on this equation solvable for p. That means we have an equation x by p. if that equation can be simplified in this form, p minus f1 of x comma y, f2 of x comma y, and so on, right? Then this can be solved by type 1 method. Now this is equal to p is equal to f1 of x comma y. Here we have p equal to p is equal to f2 of x comma y. So on, here we have p is equal to fn of x comma y. Now we know what is p. P is dy by dx, right? We have dy by dx equal to f1 of x comma y, and here we have dy by dx is equal to f2 of x comma y, and so on up to dy by dx is equal to fn of x comma y. Now you can see all these are differential equations of first order and first degree. Yes or no? Let this solution, you find solution for each term. Right? Solution for each term. You can find a solution by variable separable method or homogeneous differential equation, anything, right? Now let the solution be, right? Let the solution be. Let this solution be some f of x comma y comma c, right? You will have a solution in terms of x, y, and some constants, right? Similarly, you will have solution for this also, right? Let the solution be f of x comma y comma c. Similarly, you will have solution for this also. Just call that as f of x comma y comma c. Right? Now, what I'm going to do, or let us say this is f1, right? In order to 1, 2, and so on up to fn, right? Now, you multiply all this, that will be the solution of the given differential equation, right? So multiply all this. So general solution of one is just have to multiply all the functions of x comma y comma c, f2 of x comma y comma c, 2 of x comma y comma c, and we have and so on up to fn of x comma y comma c. Right? So very simple. If it is solvable for p, means it can be put in the form p minus some function of xy, p minus some function of xy. Now equate every term to be equal to 0. So every term is a differential equation of first order and first degree. So solve and find solution. Multiply all of them to get the general solution. Very simple. Right? You will solve, then it will be easy for you. Right? We'll directly get into the problems. Any doubt up to now? If I do 1 or 2 problem means it will be very easy for you. Is there any doubt up to now? Solve the following equation, right? Solve p square plus p is equal to 6. Remember, equation is same as dy by dx whole square plus dy by dx is equal to 6, right? You can see this is of higher degree because we have degree 2 here, right? So in exam point of view, if they give p, means that is same as dy by dx, right? This p square plus p minus 6. So this I can write this as p square plus p minus 6 is equal to 0. Now find, you just have to put it in this form, right? You just have to put it in the form. That means you need to factorize this. Factorize this, we have sum to be equal to 1, product to be equal to minus 6. We have 1, so 3 minus, right? So we have square plus 3p minus 6 0. Take p common, we will have p minus 2 common, we will have p plus 3 0. We have p minus 2, p plus 3 is 0. This is you can see we have in this step, right? It is solvable for p because I written the form p minus some function of x comma y, p minus some function of x2 of x comma y, right? Yes. Now you have to equate every term to be equal to 0. You have to equate every term to be equal to 0. That means we have dy by dx is equal to, here we have dy by dx equal to minus 3, right? Solve separately. So solve this equation very simple, right? Dy is equal to 2 dx. If I integrate this, if I integrate, we have y is equal to 2x plus some constant. Here we have dy is equal to minus 3 dx. So we have y is equal to minus 3x some constant, right? So here you can see we have find a solution for each of them separately. This is our f1, right? This is our f1 of x comma y comma 6. This is our f2 of x comma y comma. Now multiply that to get the general solution. Therefore, general, yes, you have to multiply this, right? So therefore, we have y minus 2x plus c. We have y minus 2x minus c into y plus 3x minus c equal to solution, right? We will be calling this as complete solution, right? Instead of general solution, we will call it as complete solution. The next class, just tell me the difference between what is meant by general solution and what is meant by complete solution, right? You have to tell this, right? Just take the exercise. Very simple. What is the difference between general solution and complete solution, right? You have to tell the, okay. The next problem. And is solve p square minus or pi is equal to 0, right? In this class, we're going to concentrate only on type 1. This class, we're going to concentrate only on type 1, right? Okay. Yeah, p square is equal to x power 5. That means p is equal to plus or minus x power 5 by 2. That means p plus x power 5 by 2 is one term and p minus x power 5 by 2. It is solvable for p because it can be put in the form p minus f1 of x comma y, p minus f2 of x comma y. Now you have to put everything equal to 0. So we have p is equal to minus x power 5 by 2 and we have p equal to x power 5 by 2. Now solve these equations separately. We have dy by dx equal to power 5 by 2. We have dy power 5 by 2. So we have dy is equal to x power 5 by 2 dx, right? Or minus dy. Here we have dy is equal to x power 5 by 2 dx. Now integrate this. So we have minus y is equal to x power 5 by 2 plus 1 by 5 by 2 plus 1 plus c. And integrate this. We have y is equal to x power 5 by 2 plus 1 by 2 plus 1 plus some arbitrary constants. We have minus 5 is equal to 5 plus 2 is 1, 7 by 2. We have 2 by 7, x power 7 by 2 plus c. Here we have y is equal to 5 plus 2 is 7 by 2. We have 2 by 7, x power 7 by 2 plus. So we have found solution for each of the equations. Now you have to multiply that set, right? You have to multiply this. So if I take this 7 to that side, we will have minus 1 by is equal to 2x power 7 by 2 plus 7c, right? We take them here. So therefore, here we have solution to be, if I take minus 7y 7c, x power 7 by 2 is equal to 0. And here we have 7y minus 2x power 7 by 2 minus 7c is equal to 0. These are solutions. Therefore, the complete solution is, we will call this as complete solution. Complete solution is, you have to multiply this, right? Minus 7y minus 7c x power 7 by 2, 7y x power 7 by 2, right? On the third problem, very simple, right? Solve square plus into x plus y plus xy is equal to, see, this equation is same as y by dx whole square plus dy by dx x plus y plus xy is equal to 0. Right? So don't get confused by seeing the question. Just transform. You just have to put dx equal to p. Now, if it is solvable for p, then you can easily find a solution, right? First, what we will do is we will write this as p square plus px plus py plus y is equal to 0. Take p outside, we will have p plus x. Here, if I take take y outside, you will have p plus x. Sorry. So we have p plus x into p plus y is equal to 0. It is solvable for p, right? We have p plus p minus f1 of x comma y, p minus f2 x comma y. Here f1 is minus x, f2 is minus y. We equate every term to be equal to 0. So we have p plus x 0 and we have p plus y is equal to 0. So we have p equal to minus x, and solution for this minus x dy is equal to minus x dx, y is equal to minus x square by 2 plus c. So 2y plus x square minus c. Solution for this. Here we are integrating this, right? Here we have dy by dx equal to minus y. We have dy by y equal to minus dx. So if I integrate this, we will have log y is equal to minus x plus c. So log y plus x plus c 0 is solution for this term. Therefore, the solution is have to multiply this. So we have 2y plus square minus into log y plus x plus c is equal to 0. Right? This is the required solution. So we move on to second problem. Fourth problem. All square plus 2x minus 3x square is equal to 0. Again, what I'm going to do is, you just see this as a quadratic in x, but the coefficient are not constant here, right? Here we have p square, here we have p, and here we have some. Just think it of a quadratic in p, but not the coefficients are constants. So what we can do is, we have p square plus x into p, 3x square is equal to 0, right? To see this quadratic, right? I'm just telling you just to see that, right? But not it is quadratic because here p is dy by dx. Now here we should have 2, here we should have 3. So sum is 2, product is minus 3, right? What we will have here, 3 minus 1, right? So instead of this, what we can do is, so p square, that's, now here we have 2xp, right? So what I'm going to do is, I'm going to write this 2xp as 3xp minus 1xp minus 3x square is equal to, right? So here we have xp, right? I'm just writing this 2xp as xp minus xp. That's 3x square already we have. Have one. Now we can take this p out, p common from this term. We have p plus 3x. Here we should have p plus 3x. So I'll just take minus p outside. We have p plus 3x equal. So we have, sorry, here we should take this outside. Right? We take minus x outside, we'll have p plus 3. P plus 3x into p minus x equal to 0. This is soluble for p, right? Because p minus f1 of x comma y into p minus f2 of x comma y. Equate the term to be equal to 0. Solution for each term and multiply them. We have dy by dx is equal to minus 3x. We have dy is equal to minus 3x dx. That means y is equal to minus 3 by 2 plus c. So 2y plus 3x square minus 2 equal to 0. And here we have dy by dx equal to x. Dy equal to x dx. So we have y is equal to x square by 2 plus. We have 2y minus square minus 0. Multiply this, solution is, we call this complete solution. 5 plus 3 minus 2c, 5 minus square c equal to 0. The required solution. Instead of this 2c, instead of this minus c, you can also put you can also put some c, right? All these are constant only. So you can also put it as some c. Instead of 2c, you can also put some c also. All these are arbitrary constant. Problem is solved. square plus xyp minus 2y is equal to 0. Right? This equation is same as x square dy by dx whole square plus xy dy by dx minus 2y is equal to 0. Right? So in exam point of view, this is asked, don't get confused. Right? Just put p to be dy by dx and see whether it is soluble for p. Now here we have square p square. See, you see this as the quotient is 1, right? So sum is 1, product is minus 2. Is 1, product is minus 2. So we have 2 minus 1. So just put xyp as 2xyp minus xyp, right? 2y is equal to, just factorizing this, right? So here we have, we take this xp outside. Here we have one xp and here we have 2y. And here I have to take minus yp, yp minus 2y, where xp outside. We have 2y and here we have an x. If I take, what should I take common here? Okay, minus. Sorry, question is y square, sorry. Square p plus xyp. Yes, sorry, this is wrong. Square p square plus yp y square. This cannot be solvable for p here. If you cannot factorize means you have to go for quadratic. You have to go for quadratic formula. Just right. Here we have xyp y square. Sorry. Now here you can see sum is 1, product is minus 6. So here we have 3. Right. Instead of this xyp, I can write this as square p square plus 3xyp plus 2yp minus 6y square is equal to 0. Take xp outside, you have xp plus 3y. Here if I have to take minus 2y outside, we have xp plus 3y is equal to 0. So we have xp y and we have x plus y is equal to 0. Right? Now what we'll do is we will do them separately. Right? We have xp minus 2y is equal to 0 and we have xp plus 3y. That means x dy by dx equal to 2y, but we have dy by dx equal to 2y by x. So this will be dy by y is equal to dx by x. If I integrate this, we will have log y is equal to log x plus some log c, same as log of y by x square, right? So log a minus log b is log a by b, and take this 2 to the power is equal to log c. So we have y is equal to the square is a solution for this, and here we have x dy by dx equal to minus 3y. We have x dy is equal to minus x, and we have dy by y is equal to minus x by x. So y is equal to minus 3 log y is equal to minus log x plus log c. So log a plus log b. So we have log ab equal to c. Solution for this. Therefore, the solution is you have to multiply these two. So y minus x square yx cube minus c equal to, right? Here, right? We'll move on to sixth problem. Solve y square plus xyp minus x square p square is equal to 0. Right? Equation is same as x square p square minus xyp minus y square is equal to 0. Right? Now, very carefully here. what we have sum here? What's the here? Sum is -1 and product is -1 again, right? Now you cannot possible to find these two numbers. So it's not possible, right? Sum has to be -1, product has to be -1. So if you put minus to 1, it's not possible, right? It is not possible. Right? You cannot find two integer coefficient, right? Okay. Now what we'll do is in integer coefficient is not possible, right? Okay. So what we'll do is we will go for quadratic formula. This is same as x square p square plus xyp plus y square is 0. So we need to solve for p. So p is equal to minus b star minus root of, see, this is our a, our b, this is our c. A, c. So minus b minus root of b square minus ac divided by times a. See, you cannot find two integer here, right? Integer. Then you go for quadratic formula. We have xy plus or minus root of p plus. So we will have this be 5 times x square y divided by 2x square. This will be xy plus or minus 5xy, right? Because the x square root is xy divided by 2x square. Now, if what we can do is we can cancel one x, right? X. So we have y star minus 5y divided by 2x, right? This is our dy by dx. So we have two terms, right? So we have dy by dx is equal to y plus. So we have two solutions now. Y by dx equal to y plus root 5 y by 2x, and similarly other will be dy by dx equal to y minus root 5 y divided by 2x. Now solve these two equations and multiply them to find that to get the complete solution, right? So what we can do is we can take this y outside, right? We have dy by equal to y into 1 plus root 5 divided by x. We have dy by y is equal to 1 plus root 5 by 2 is constant. Dy by y into dx by x. Integrate this, log y is equal to log y is equal to 1 plus root 5 by 2 log x plus some constant log c. So this will, we cross multiply this, we will have log y square is equal to 1 plus root 5 log x plus some log c1, right? Plus some logs, 2 log c will be there. That is called from log c1. So log a minus log b. So log a minus log b. So we have y square minus this term. So same as x power 1 plus root 5. You just have to take this to the power. Log of x power 1 plus root. Log a minus log b is log a by b. So we have y square divided by x plus 1 by root 5 equal to some constant c1. Or you can also write this as y square minus 1 into x plus 1. This is one solution. Finally, you do this also. We have dy by dx equal to, if I take y outside, we will have 1 minus root 5 2x. We have dy by y. Here 1 minus root 5 by 2 is constant. We have dx by x. Log y is equal to 1 minus root 5 by 2 log x plus some constant log c. So cross multiply this, so we will have y square minus, right? This x power log a by log b. So log a by b. Have y square 1 into x power 1. Therefore, solution is not multiply this, y square minus x power 1 plus root 5 square minus 1 x. Want to sound? solve square p square xyp plus 2y square minus x square is equal to 0. Right? Now you can see quadratic, right? But not of constant coefficient. P square p and some constant. What you can do is you can directly go for quadratic formula. So we have b is equal to minus b minus square root of b square minus 4 times c divided by 2 times a. So we have this to be xy plus or minus root of 4x square y square. Multiply this, we will have minus 8 square y square plus 4x power 4, right? 4x power 4 will be now okay, we have 2xy plus or minus 3, 4 minus 8 is minus 4. We have 4x power 4 minus 4x square y square divided by 2x square. Then we have 2xy plus or minus. I can take 2x square outside, right? Take 2x outside. This I can take 4x square common. If we take 4x square common, here we have 2x. Here we have one x square. Here we have one y square divided by 2x square. So 2x, x, and this 1 2x will get cancelled. So we have 1x here. We have y plus or minus square root of x square minus square divided by x, right? So we have dy by dx equal to y plus or minus root of square root of x square minus square divided by x, right? Let this be plus or minus, right? Let this be plus or minus. Can find two solutions from here. Let this be plus or minus. Now you can see this is a homogeneous differential equation, right? So we have dy by dx is equal to f1 of x comma y divided by f2 of x comma y. So both f1 and f2 are homogeneous of same degree, right? Of same degree means that is homogeneous differential equation, right? So put y is equal to dx, or you can also put x is equal to uy, right? You can do anything. We will always use this as major. So what we will do is this homogeneous, it is homogeneous differential equation. No, so both are homogeneous functions of degree 1. Put f of tx comma ty, we will have t f of tx comma ty into f of x comma y. Here also f of tx comma ty is again f of f t into f of x comma y. So both is a homogeneous function of degree 1. Each of degree 1. Also homogeneous of degree 1. Homogeneous of degree 1. This is also homogeneous of degree 1. Right? That means you have to solve this homogeneous differential equation now. So we have dy by dx to y plus or minus root of x square minus y square divided by x. Right? So put out, you need to know how to solve this equation, right? So put y is equal to bx. So we have dy by dx is equal to v plus x into d by dx. Call this as 2. Substitute 2. These two substitution in this here. So we have dy by dx equal to y plus or minus root of square minus square by x. So what is dy by dx? It is b plus x in dv by dx. And we know what is y. Y is x divided by x. So this x, take this x outside, all these x will get cancelled. So we have b plus x by dx equal to b plus or minus root of 1 minus b square by 1. This b minus b plus or minus of 1 equal to minus by dx, right? So we have minus b is always 0, right? So minus b is always 0. We have s r minus root of 1 minus b equal to minus x d by dx. Use variable separable here. So we have r minus root of 1 where x equal to minus x d. So this will be d minus x by x equal to r minus root of 1 square. That's it, right? So to integrate this, we will have here there are two solutions here. We put plus here, we will have one solution. Minus here, we will have another solution. So this is sine inverse of v, right? A square minus x. This sine inverse of v. This minus log x. Or minus the sine inverse of v, right? Sine inverse of ax is sine inverse of a is 1 by root of 1 minus a. To integrate this. Plus we will have some constant. Let us call that to be equal to some c. So the solutions are minus log x is equal to plus sine inverse plus c minus log x equal to minus sine inverse c plus c. Right? Therefore, the complete solution is how to product this minus log x sine inverse of v minus 2 log x plus sine inverse. Right? Very simple. If it is solvable for p means either you can able to factorize this, or if you not able to factorize, that is if you not find two integer means go for quadratic formula. You will have reduced to one of the methods of solving a differential equations of first order but not of first degree. Right? Yes. Or y square plus x square plus xy plus p square p square into p plus x plus xy is equal to 0. Right? You need to solve, right? Now what I'm going to do is I'm just going to make some simplification here. This x y p square plus x square p plus xy p plus y, and we have x square y is equal to 0, right? Now here I can take xp common, I can take yp common, here I can take x common, right? If I take xp common here, we have yp plus xp, right? Here we can take yp, take xp common here, we have. Okay, so what we can do is, of this what we will do is common here, sorry, this is x square p, right? Square p, take xp common here, now yp, here I can take yp common, right? So this will be x here, and here we will have one of that. So what we will try to bring yp plus x, right? So we will try to bring yp plus y. If I need yp plus x, yp plus x, what will x? So what we'll do is instead of we will take here these two common now. So here if I take take x common, we will have yp plus x, because we have yp plus x here, right? And here I take y common, again we will have yp plus x, right? I'm just going to group these, group like this, right? Now you can see yp plus x, yp plus x, yp plus x, and write this as xp plus x plus y into yp plus x is equal, right? Now you have to equate every time to be equal to 0. We have x plus y is equal to 0, and we have yp plus x is equal to 0, and we know what is p is dy by dx, right? P is dy by dx. Okay. Yeah, so very simple, right? So x into dy by dx is equal to minus x minus y. Here we have y dy by x equal to y dy is equal to minus x dx. So this solution is very easy. Y square by 2 is equal to minus square by 2 plus. So we have found one solution. Now here we need to find the other solution, right? Yes. Now this is x dy is equal to minus half x plus y dx. Super. So here it is of the form x plus y dx m dx plus n dy, right? It is of the form m dx plus n dy, and you can see it is an exact differential equation, right? Because dou m by dou y is equal to dou n by dou x, right? It's exact. You can check it out, right? What is the condition for exact differential equation? Dou n by dou y dou m by dou x equal to dou n by dou y, right? What is the condition for exact differential equation? We have m dx plus n dy is equal to 0. It will be exact when dou n by dou x plus dou m by dou y is 0, right? We already solved these. What is the solution for exact differential equation? Integration of y constant m dx plus integration of terms in n not containing y dy dx equal to 2. I just have to recall all those, right? Read this exact. What about this Bernoulli? What about, yes, exact, right? So we have m dx plus n dy, so it will be exact when it will be exact when dou n by dou x equal to dou m by dou y, right? So we have dou m by dou y is equal to dou n by dou x. Then we say it is an exact differential equation. Solution is integration of m dx plus integration of terms in n not containing x dy is equal to c, right? This is solution, right? So again you can see it is also exact because dou n by dou x is equal to dou m by dou y. So it will be exact because dou m by dou y is equal to dou n by x, right? Because for m dx plus n dy, with respect to x we will have 1, and with respect to y again we will have 1. So this exact differential equation. Its solution is integration of m dx plus integration of terms in n not containing x dy, right? Terms in n not containing x dy. Solution is of yes, yes. Here you have to replace this. Sorry. Yes, yes. You have to just replace this b by. Thank you. Here we have y is equal to bx, so b is equal to y by x. You have to replace this b to be y by x. Okay. So this is integration of So integration of mdx, take y as constant here, plus integration of terms in n not containing x, not containing x dy equal to some constant c, right? So terms in n not containing x dy is equal to c. This one, right? Terms in n not containing x dy is equal to c. Now we will do this, integrate this. So integration of f dx, integration of x plus y dx, not integrate by taking y as constant here, plus integration of terms in n not containing x. So no term does not, there is only one term in n and that term contains x. Therefore it will be 0. That term will be vanished. So integration of x dx is x square by 2. Here you will take y as constant, right? So plus yx is plus yx equal to c, right? This is the solution of this equation, or x square 2yx minus c is equal to c. We will have 2c, not at all a problem, right? These two are solutions here. Therefore, complete. So this will be y square x square minus c. Right? We have 2c, no problem, right? Here we have x square yx minus c. Right? This is 1, 2 next problem. 9th problem. Solve I will do another 2 more problem and then we'll wind up this. Solve x y square b square 2 plus 2x y square. Now we take x common here, we will have y square b square minus x square, and here if I take this minus 2y square constant, we will have y, right? Take minus 2y square constant minus y square. We have yp, here we will have minus x, right? Now y square b square minus, so what we can do is a square minus b square, right? B, a minus b, a plus b. Take it as yp whole square minus x square. Here we have 2y square yp minus. Now I can take this yp minus x, right? If I take yp minus x outside, we will have x yp plus x minus y square is equal to 0. We have yp x into, here we will have x yp plus x square minus y square is equal to 0. Right? Now you can see it is of the form, right? It is of the form, it is solvable for p. Now you equate every term to be equal to 0. So we have yp minus x equal to 0, and we have xyp plus y square is equal to 0. So y dy by dx is equal to x. We have y dy equal to x dx. So we have y square by 2 is equal to x square by 2 plus. So we have y square minus is equal to some constants. Or put c1, right? No problem. And here we have xy dy by dx is equal to y square minus. So we have dy by dx equal to y square minus x square by xy. So it is homogeneous of degree 2. This is also homogeneous of degree 2. This is a homogeneous differential equation. So put y is equal to vx. So we have dy by dx is equal to v plus x by dx. Substitute these two here. So we have y by dx equal to y square minus x square by xy. So what is dy by dx? V x into dv by dx 2 into v square divided by x into x square get cancelled. So we have v plus x by dx equal to square minus 1 by v minus 2 square minus 1 by v is x dv by dx. So v square plus 1 by v equal to x dv by dx. So here we have minus square plus equal to minus x dv by dx. So if we cross multiply this, we will have by v square plus 1 plus 1, and here we will have x by right minus x. Now you have to integrate this 1 minus or what we can do is rolled by minus. So let's put minus here dx by in this minus to this side. Now we can see f of v, f dash of v. So that means 2 is missing. So we'll multiply and divide by 2. Now if we integrate this f of v, f dash of v, log of here equal to log x plus some constant log c. This log of b square minus 1. Now it is very simple, right? Same as log of root of 1 minus. Okay, let us write this as log of minus b square is equal to log x square plus log c, right? If you multiply this 2 here, take the 2 to the power. So log a minus log b. So it will be log a by b, or you know y is bx, will be y by x log of square minus square by x square, right? Y square by x square. Here we will have log of x square plus log c. So log a minus log b. So it will be log a by b. Log a by b by x square means log a minus log b x square. X square will get cancelled. So we will have this term to be equal to log of log a minus log b. What's this? Log of square minus square by or 4 log c. We have c x power 4 is equal to x square minus another solution. Therefore, solution is just have to multiply this and right. Solution is minus x square y square minus x square is minus c, and this solution is x power 4 minus square. Very simple problems only. Here equation solvable for y. Right? On to the last problem. Solve p square minus square y square plus y power 4 by x square by x plus square x square is equal to 0. Very simple problem, right? Just show the solution. Very simple, right? You just have to take some terms common. So here we have p square y by xp. Just take these three terms one side. Here you take this p square y square outside, and write this as minus y by x whole square, right? A minus b whole square formula. A square minus b square. Again, we have x minus y whole square, p square y square. This x square take to that side, it will be 0. Now you need your term to be equal to 0, right? And you can see here it is of the form. First, we have to group these three terms. This term, this term. Right? Here you take this p square y square outside. Same as p minus y by x whole square. Now, same as px minus y whole square minus p square x square minus y. Overall, we will have x square. Take that to that side. Now again, you can see the form a square minus b square, right? A square minus b square. So it will be like a plus b, a minus b, right? I can write this term as py into of a minus y square whole square. Now it is of the form a square minus b square, right? Because we don't have whole square here. So py into of a giving square inside, you will have this term, right? P square y square. This square will get cancelled. So this is our a square minus b square, a plus b, a minus b. Now separate it down to be equal to 0. We will have plus or minus. Again, so homogeneous. Here we have dx by dy. So if you have dy by dx means put y is equal to bx. If you have dx by dy means x is equal to dy, right? All are simple, same process one. Now integrate this. Have the formula to be this is cos h inverse of this is the required solution. The problem. You just put it out. It will be very easy, right? That's it. Mind of this type 1. So type 1 is equation solvable for p, right? For p. The next class you will start type 2 where it is equation solvable for y, right? Instead of p we will have y. What is p? P is dy by dx, right? So that's it. This is the next class, right? Thank you.